All right, so here we have a table problem. So right away when I see this, I expect that I will be asked to approximate either a derivative or an integral using a difference quotient or a Riemann sum. And sure enough, in part A, I'm asked to approximate C prime of 3.5. So that would be between 3 and 4, obviously. So I'd be like C prime of 3.5. And the approximation of a derivative is, of course, an average rate of change. And you do want to show this because this is often worth a point in the rubric. And this is one of the easiest points that you can get. And notice my denominator is 1. I could easily do this in my head, but this altogether is what the reader is looking for. So make sure you don't simplify anything yet, even though you can obviously do that in your head. And I get 1 on the bottom and 1.6 on top. And notice in the text it says show the computations. That's my computation. And then it says indicate units. So if I have ounces per minute, y is per x, there's my solution. In part B, I'm asked to use a trapezoidal sum, and I actually edited it since I made this. It should be 1/3 times the integral, right? And I'm asked to approximate, so I'm going to rewrite just my integration statement. 1/3 times the integral of c of t dt. And then I'm approximating, so we can use the curly equal sign. I'm going to leave the 1/3 in front. And then my trapezoidal sum, always 1/2 times the sum of the bases times the height, right? And in this case, my height is 1. It's the change in x, right? And the sum of my bases is 0 plus 5.3. And that's my first one. And I'm only going to 3, which is nice. My next one is going to be 1/2 times 5.3 plus my next x is 8.8. And again, my height is 1 because it's the change in my x is 1 every time. And then my last one is 1/2 times 8.8 plus 11.2 is my last x times 1. Okay. And you can also write this in kind of factored form. So Riemann sums often, or trapezoidal sums often, values appear in every term. So I can factor out a 1/2 and a 1 because my change in x is constant in this case, times 1/2 times 1, and then it would just be 0 plus 5.3 plus 5.3 plus 8.8 plus 8.8 plus 11.2. Okay, and that's fine to leave it like that as well. Either of these, I can just draw a box around this and call this my answer. So notice this arithmetic is kind of cumbersome, right? It's a no calculator question, and I got all these decimals, so no calculators allowed. I got all these decimals that I'm supposed to add up. You do not have to simplify this on the AP exam. You do have to indicate units, but I don't have to give a number here. I will give you the number. What we get is 6.566 is our value, right? But I don't have to actually give that. I do have to write my interpretation. So I have to explain what my result means in the context of my problem. And this 1/3 makes it an average value. So before we do that, though, just like make a note of how much simpler our life is if I don't simplify that value, right? So I have to set this up for the reader anyway, right? I have to write my trapezoidal sum so that they can see my method. I get a point for that. And then if I go to simplify this, I might make a mistake. In fact, I would probably make a mistake for sure because arithmetic is not my strong suit. So I'm just going to leave it alone. I got to write it anyway. I get no extra benefit for trying to do the math here. So this is my average value of C of t is what I found, and it's in ounces. So my interpretation is I can say this is the average amount in ounces. And then my noun is the amount of coffee in the cup according to the text, right? And then I'll give a time from t equals 0 to t equals 3. Okay, so there's my interpretation, and I would get a point for my setup and a point for my interpretation with correct units. We can even say t equals 0 to t equals 3 minutes if we want to make this perfect. All right, my final two. Here's my part C. Is there a time at which C prime of 2 is equal to 2? So I don't have C prime of 2, right? I just have values of C. So this tells me that this is a mean value theorem, right? So right away when I read this, I would think, okay, this is definitely mean value theorem. So I need to state two things right away, right? And I notice that C is differentiable and therefore is continuous. And I'm asked if C prime of t equals 2, right? So what I need to know is there ever an average rate of change equal to 2? And here's where you have to kind of look at the table, and here's where your mental math skills are going to pay off a little bit, right? So what I notice here is we have from here to here an increase of 4, right? Over a change of 2, right? So here's 4, here's 2. That's going to be an average rate of change of 2, right? So I would say from C of 4 to C of 2 is the interval I'm interested in, and it spits out 2. So my conclusion then is that since C of t is continuous and differentiable and the average rate of change, it's okay to abbreviate that, by the way. They will know what that means. From t equals 2 to t equals 4 is 2. There must be a t such that C prime of t equals 2 by the mean value theorem. And again, it's okay to abbreviate that. Good. So notice what I definitely need to say is that C is differentiable and continuous, and I need to say that there is an average rate of change that is equal to 2. And it's a pretty good bet that if they're asking you this, there is a spot in the table where the average rate of change is 2. Otherwise, it would be kind of a silly question to ask you. All right. Last one is the amount of coffee in the cup. What are we saying? The amount of the coffee in the cup in ounces is modeled by B of t. Find the rate at which the amount of coffee in the cup is changing. So this is just like, can you interpret the text? If it's the rate at which the amount of coffee in the cup is changing, this is really just asking you for B prime of 5, right? So I'd say here, you could use a calculator. Oh no, you can't use a calculator for this, so there's no calculator. So I would take this derivative by hand. I'd be like B prime of t. The derivative of this is 0, and then I'd have negative 16 e to the negative 0.4 t, because the derivative of e to the anything is itself, and then I do chain rule times negative 0.4. Okay, this is another situation where like I may not be able to simplify this without a calculator, right? That is fine. I'm asked for B prime of 5, and that would be equal to negative 16 e to the negative 0.4 times 5 times negative 4. I could again draw a box around that and say give it a label. So this is ounces per minute, and I am done, right? I do not have to simplify that, and they don't care, right? In fact, they are not expecting you to write a decimal here because you don't have access to a calculator. If you wanted to, again, I would advise against it. You could simplify a little bit. You could say 0.4 times negative 16 is 6.4 e to the negative 0.2, right? That is equivalent. That would also be okay, but you don't need to do that, and like don't worry about it, and don't panic that you can't simplify all of your decimals. All equivalent forms are allowed.